All right, in section 2.5, we're talking about linear inequalities. So inequalities, when we see this, the prefix inequalities basically means not equal. So when we're looking at linear inequalities, we're going to compare this to what we've done with linear equalities or linear equations. So remember, we had equations, two things were actually equal. And we used properties of equations, compositional properties of equations to help solve them. But what if things are not always equal? So we use inequality symbols like less than, greater than, less than or equal to, greater than or equal to, or even just an equals with the line through it, which is not equal to. And they're used to compare values that are not always equal. And again, when we read these, we just have to understand the direction of the symbol when we read it. So instead of saying like -2 is not equal to 5, which of course it's not, we can be more descriptive and say, well, -2 is less than 5. Okay, and of course that's true. And then we can say -2 is less than or equal to 5. So the equal sign, remember that's a less than or equal to. And for an or statement, just one or the other needs to be true, or both. But so since a -2 is less than 5, then -2 is less than or equal to 5. So we could actually use this less than or equal to as a side note. We could also say that 5 is less than or equal to 5. That's also a true statement because, of course, it's equal to. So again, we just have to be careful in how we do that. So the less than sign, I mean, we could actually talk about the 5 first. We could reverse the numbers and use the following inequalities. So in this case, 5 is compared to -2. We would have to have the inequality written this way, which is greater than. This would be greater than. And then we could also have greater than or equal to -5. So again, we could switch the way the numbers are represented, but then we need to make sure we switch the sign so it is read correctly. So eventually I want us to be able to read these inequalities in both directions. We should be able to read them from right to left as 5 greater than -2, or from left to right, basically saying -2 is less than 5. So we'll get used to that in a little bit. So when we have inequalities, the nice thing about it is that they actually represent, if we want to represent numbers, if we looked at a graph on a number line, if we looked at a graph of x equals 2, then the number line really doesn't help us, explain more about what x equals 2 is. We could basically say x equals 2 would just be notated on a number line as 2, as a solid dot. The number line, remember the arrows on the number line basically say that these numbers keep going off to infinity and -infinity. So that's why the arrows are there. And infinity just means it keeps increasing without bound, and -infinity means it's decreasing or going to left without bound. So if you think about what this inequality is saying, the x represents any number. So this would be any number. And then greater than or equal to, right? That's this sign. It's greater than or equal to -2. Well, on a number line, it just gives us a quick visual. So here's x equaling -2. So we could look at this and say it's x is greater than or equal to -2. So -2 would be a point, would be a value that I want to represent as a number that's greater than or equal to -2. So we definitely want that as part of my answer. But then what represents all the numbers greater than or equal to -2? And on a number line, that would be all the numbers to the right. So what we do is we draw a bold arrow to the right. So when we graph something, we want a visual. This is a quick visual representation of the solutions. Sorry about that. All right, so x is, if we go to the next one, x is greater than 1. Or excuse me, not x is greater than 1. This is less than. X is less than 1. And that does not include 1. So when we look at this, 1, I know less than would be all the numbers to the left of 1. So I know I want a bold arrow on the number line representing everything to the left of 1. But what do I do at 1? And I can't put a solid circle there, because we would interpret that as 1 being part of my answer. So instead, we use an open circle at 1. And this would represent everything, all the numbers less than 1. Okay, so here's less than, and we know to the right of the number line would be all numbers less than. So we do need a bold arrow representing the numbers that are less than. It says -3, if you notice, like -3 is less than 1. 0 is less than 1. So everything under the bold arrow. And then an open circle, this open circle is basically like a boundary. Okay, a closed circle, when I have it closed, that's also a boundary of, or the start of my arrow, but it is showing me that I want to include it. Okay, so in the textbook, you might see some notation that looks like this. So here's some similar notation on a number line. Wait, let me get that a little flatter, I guess. If they were going to represent this at -2 and everything to the right of -2, again, we would use a bold arrow to the right. But in the textbook, instead of a closed circle, what you might see is a bracket like this. And there, I'll explain why that is. At -2, you'll see a bracket facing the arrow in which we're headed. And this is the same exact thing as x being greater than or equal to -2. So instead of a closed circle, they might use a bracket. And instead of an open circle, if they were going to represent on an open circle, here's 1, they would represent all the numbers to the left with a bold arrow on the top or over the top. And then at 1, you would see a parenthesis in the direction of that arrow. And this, again, would represent all numbers x strictly less than 1. Okay? So again, I am very partial to open and closed circles. So I'll be probably using open and closed circles almost exclusively, but I'll tell you why in a little bit, why we use brackets and parentheses. So let's do this last one. What if -1 is less than x? And this time you notice the x is on the right side. And if we read, and this is kind of a tip, I want to read this inequality starting with x and reading basically right to left. And it'll help us understand what values we're talking about. So if we read -1 is less than x, then if you think -1 is like a boundary, and it's open because it's not including, it's not equals. So we know it's an open circle at -1. There's our boundary. And if we're trying to figure out which side to draw our arrow, let's just pick a number. So like if we think because of the less than, that the arrow must go this way, then we should be able to check a number like -3 and see if it works. If we check this, we get -3, or excuse me, we get -1 less than -3, and that's false. -1 is not less than -3. So if we check a number over here like 2, and if we check 2, we notice that -1 is less than 2, which is true. So really this one, it actually represents the numbers to the right on the number line with an open circle. Okay, so now if you think about how we're going to remember that, if we read starting with x, then we would say x, and as we get to the inequality sign, notice the bigger end is pointing towards x. That sign would point towards x and then the -1. And if we read this, x is greater than -1, then we can kind of see why the arrow is pointing the way it is. So this is what I was talking about. When we see inequalities, we should be able to read them left to right and right to left. But you can always just check numbers to make sure the arrow is pointing in the correct direction. So a graph is a quick, fast visual. If we look at another way to represent the numbers in an inequality. So an interval notation is another way we can represent solutions of inequalities in which the smallest and largest values of the solution are represented. Interval notation reflects the idea of between to represent the solution. So to represent all numbers between -1 and 4, we would write an interval notation as, so this is interval notation, and it looks like coordinates, right? But it's interval notation, and it represents on the number line everything between -1 and 4. Now, if you're between, you're not at -1 or 4. Like -1 is not between -1 and 4. 4 is not between. But we want to represent all the numbers between those two. So you notice how there's, again, this represents between two numbers, not including -1 or not including 4. So we call those the endpoints. But you notice the interval notation basically gives us a starting number, -1, and then the ending number, 4, of your interval. So an interval is a start and stop and all the numbers between. So if an endpoint is included, we would use a bracket in the notation on the included endpoint side. So to represent all the numbers between -1 and 4, including -1, we would write the notation this way. And notice that this is a bracket and it includes -1. So the difference in our graph is at -1, then we would have a closed circle and then an open circle at 4 and everything in between. Okay, so that's just different ways. This is new, this interval notation. We'll practice with it in a second here. So what if, if we see a graph of a solution, write each graph solution in interval notation. So when we read this, we have a start and we have a stop. The smallest and largest, notice it starts at -3 and it's stopping at 3. It does not include 3, but it includes 3. Excuse me, right? It does not include -3, but it includes 3. So the start is at -3 and it stops at 3. If it doesn't include -3, we use a parenthesis on that side. And again, it's always smallest to largest. And then at 3, because it includes it, we have a bracket. So this would be the interval notation for that. So what happens if we got, notice the right side goes on forever, right? Or it increases forever. It never stops, right? So this interval, this has a starting number. It starts at -12, so that makes sense. But where's the end? Where does it stop? And with that arrow, it's basically showing me that it never stops. So how can we represent that? And we go back to what we were talking about with lines, is that the arrow basically represents that these numbers go on forever. And a way to represent that is with infinity. So what we do in interval notation is that we use the symbol infinity to include, or to basically represent, all the numbers that are basically bigger than -12. And as a side note, if we thought about the graph of this, wouldn't this graph, if these were x values, the graph would be x is strictly greater than -12. That would be the inequality for it. Okay, now the last one, now this one, if you think of the interval notation, the right side is the stop. It ends or it stops. This is the right side. Okay, the arrow just represents where it came from, the left side, right? Left, or the starting point. And since there's an arrow to the left, that means there is no starting point, or the starting point decreases without bound. So for interval notation, we would use -infinity to represent that. And then it stops at -3. And it's a bracket because it includes, right? It includes -3. So if you think about how can we represent something that doesn't start, the left, the smallest number is not represented, right? Because of this arrow, we use -infinity to represent that. As a side note, if these were x values, these would be x less than or equal to -3. That would be the interval notation for that. Okay, so that's introducing inequalities. When I have inequalities, we want to use a graph to interpret what that means. It's a quick visual on what we're representing. So like all numbers between -1 and 4. The graph is a quick, fast visual of the inequality, right? Everything to the right must be greater than, and so on. Right.